Afternoon, everyone, and welcome to the next installment of DNALC Live. This is Amanda McBrien, and I'm here to present you with The Mystery of Anastasia. Just so you know, there is a workbook that you may have printed. There are lots of questions in the workbook. I don't plan on stopping to answer the questions in the workbook, but this session is being recorded and will be available to peruse at your leisure at a future date if you would like to complete the workbook pages or you've been assigned to complete the workbook pages. There's also a website, which I will tell you about at the end of the presentation, where you can access some of the interactives that I'll be demonstrating during the lesson. But I'm going to share my screen with you now, and we're going to go ahead and get started. So as you already know, this activity is called The Mystery of Anastasia. You may or may not know who Anastasia is. Take a look at the picture. You might be able to figure a few things out about her just by looking at the photograph. So it looks like she's a young girl. She's wearing a string of pearls. Her hair's done up very nicely. She's in a very nice piece of furniture. What might you surmise about this young girl, just based on her appearance? She's certainly posing for a photograph. It's black and white, looks kind of old. It turns out Anastasia was a princess, a Russian princess. And here she is with her family, the Romanov family. Anastasia was the youngest daughter of Tsar Nicholas II, who's the gentleman you see seated in the center of this family portrait. He was the Tsar, which is like a king of Russia, for about 20 years, up until 1917, when the family disappeared. But I digress. We'll get back to that in a minute. Anastasia's mother, Alexandra, is seated behind her, and she was actually from England, not from Russia. So the marriage of Tsar Nicholas and Alexandra united two royal powerhouses. Behind Anastasia also are two of her sisters, Maria and Tatiana, and to her side, Olga. So she had three older sisters and one little brother, Alexei, who was the heir to the throne, which means, you got it, he was next in line to be the Tsar. It turns out in Russia during Anastasia's youth, and by the way, this photo was taken in about 1910. So as she was growing up in the early 1900s in Russia, her father's popularity wasn't so positive. And in 1917, there was a revolution started by Vladimir Lenin and a socialist party called the Bolsheviks against the Tsar. This was during World War I, and morale in the country was very low. There were a lot of very poor people who were unhappy with the monarchy, with the way the Tsar was running the government, and they decided to revolt. Vladimir Lenin was a very smart man, and he managed to get a lot of politicians who had been working for the Tsar to sneak around behind the Tsar's back and work for him. And in 1917, Anastasia's father, Tsar Nicholas, was forced to abdicate the throne, to give up his power. And thus began the Russian Revolution of 1917, which went on for almost 2 years. Vladimir Lenin did not want the Tsar to ever resume power. So one of the first things he did was he had the royal family, the Tsar, his wife, their children, removed from their lovely home in St. Petersburg, which used to be the capital, and they were put on a train and shuffled off to Siberia. So where is Siberia? Siberia is part of Russia. It's the northern part of Russia. Parts of Siberia can be very inhospitable, very cold most of the time. Maybe the ground will thaw 2 months out of the year. From what I've heard, there used to be prisons. There may still be in Siberia. The royal family packed up their things during the revolution and started to be shuffled from place to place in Siberia. For about 1.5 years, Vladimir Lenin and the Bolsheviks kept the family on the move, and we know that at some point they wound up at this house in Siberia, in a small town called Yekaterinburg. We know that they were there because by the time anyone heard that maybe they were there and got there to possibly rescue them, they were no longer there, but their clothing was found there. There was evidence that the family had been living in this house for some period of time in 1918. There were rumors in the village that the family had been spotted there. So the White Army that supported the monarchy marched up there. And by the time they got there, instead of finding the family, In the basement, they found a room that looked like this, a room that was covered in bullet holes. There were bullet casings on the floor, blood, a piece of a finger was found. It was the site of a massacre. Word spread quickly that the royal family may have been killed at this house in Yekaterinburg. But let's think about this. Does this evidence found in the house really show that the family died? What evidence would need to be found to prove for sure, 100%, that the family was killed in this house? They need bodies. There were no bodies found in this house in 1918. There were no bodies found in the village. No one in the village wanted to speak of what may have happened in this house. There was a search around the village and the surrounding forest for possible graves. Nothing turned up. So the general consensus was it looked like the family probably was killed at this house by the Bolsheviks during the Russian Revolution. The Tsar and his family were gone. After this, Vladimir Lenin successfully took over the government, and Russia became the Soviet Union and remained the Soviet Union for about 75 years. But there were rumors that maybe the children had survived. How could they have possibly killed everyone? What a horrible act. And then in 1920, there was an interesting turn of events. So about a year and a half after we think the family was probably killed, a woman turned up in Germany. She was found in a canal in Berlin. She had thrown herself off a bridge, was rescued by a policeman, brought to a hospital, and cared for about a year and a half. The woman had a Russian accent, but wouldn't tell anyone anything about where she came from, nor would she provide a name. So she was known in the hospital where she was cared for as Miss Unknown. The assumption was that Miss Unknown was a Russian refugee. Unfortunately, at this time after the revolution, there were a lot of people fleeing Russia to surrounding countries looking to make new homes. But Miss Unknown had a secret. She confided in a hospital worker about a year and a half after she was rescued that she had a true identity that no one knew. She said that she was Anastasia Romanov, the youngest daughter of the Tsar. Now you'll see in this picture I'm showing, it doesn't say Miss Unknown any longer. It says Anna Anderson. When Miss Unknown announced that she was the youngest daughter of the Tsar, who everyone thought had died during the Russian Revolution of 1917, word spread quickly. She decided to use this name, Anna Anderson, to maintain her anonymity, to be able to travel without people knowing who she was. She had become somewhat of a local celebrity. And as word spread, it reached places like England, where Anastasia's mother was from, where there were first cousins who knew Anastasia very well. Now let's take a step back and think about this. What do you think the reaction was when Miss Unknown announced that she really was a member of the royal family? I think it was a mixed bag. So there were a lot of people who doubted her, who believed that she was a fraud and was really just trying to get rich or famous. But there were some people who thought on the bright side, maybe she really was the princess. Maybe she somehow survived the massacre. Wouldn't it be a really nice ending to a horrible story? So the cousins rushed to her bedside. They all wanted to meet Anna Anderson and really find out if she was who she said she was. When they met her, they were uncertain. There were a lot of similarities. She was the same height as the princess. She had the same hair color, same eye color. There were some other interesting things. Anna Anderson had a damaged finger, just like Anastasia did. She had a scar on her foot that looked like it was from a bayonet. That's that knife-like attachment you can put on the end of a gun. That's what Russian soldiers used to carry. If she was really the princess, it would make sense that she might have a scar like that. In fact, she was covered in scars. That jives with the story of being kidnapped by the Bolsheviks and held captive. But when she was interviewed, she could answer some questions about her childhood, but not all. She could identify some people in pictures, but not everyone. And the cousins from England were not convinced. In fact, shortly afterwards, they denounced her. They said they did not believe that Anna Anderson was being truthful. When she came of age and was the age where she could rightfully receive inheritance from the royal family, she sued the family, and a court case ensued. The judge said that she could not receive any inheritance until she proved in a court of law that she really was the Grand Duchess Anastasia, the missing princess. As the court case started to unravel, an article came out in a local German newspaper about a woman named Franziska Schankowska. Now, bear with me, this is important to the story. In the article, the journalist reported that Franziska was a Polish factory worker. She disappeared from her village in Poland and had been residing in a boarding house in Berlin, Germany. She disappeared from her boarding house in 1920 at almost exactly the same time that Anna Anderson was found in the canal. Franziska's family reported to the journalist that before her disappearance, she was involved in an accident at her workplace, a factory where they actually were making grenades. There was an explosion. She was within range, and as a result, wound up being covered in scars. Wait a minute, who else was covered in scars? Anna Anderson was covered in scars. The journalist suspected in the article that maybe Anna Anderson was really Franziska. The paper didn't really go anywhere. The article was published, and shortly thereafter, it was found out that the journalist was paid by the royal family to write the article. So it didn't really have much leverage in the court case that ensued. What we're going to do now, though, is look at some of the evidence. So how, let's say it's 1924, can you prove if this woman, Anna Anderson, really is the princess? I teach this class a lot to young students in middle school. And the very first, most logical answer always is, why don't we just look at her DNA? Well, if that had happened today, this mystery of Anastasia, that would be a pretty easy solution. But in 1924, not a possibility. We didn't even know the structure of DNA in 1924. Nonetheless, have the ability to use DNA to identify people like we see in movies and on TV. The second most common answer is, why don't they look at her fingerprints? That's a great idea. Well, if we can get her fingerprints, we're halfway there. But who else's fingerprints would we need to use fingerprinting analysis? We'd need Anastasia's fingerprints, which no one had. So that piece of evidence, not possible. So beyond a physical likeness, they look a lot alike, they have a lot of similar physical traits. I'm going to show you some of the evidence that was used in this case. One of the pieces of evidence was handwriting, and this is actually still a technique that's used by detectives today. Luckily, they were able to obtain the princess's handwriting samples from journals that she had left behind. So in pink on the left-hand side here, you'll see Anastasia's handwriting samples, small excerpts from her journal. And on the right are samples written by Anna Anderson. And we can do a little comparison here. So when we're doing a handwriting analysis, do we expect to see an exact match? Well, think about your own handwriting. If you were to write your name 10 times on a piece of paper right now, would each be exactly the same? Probably not. But handwriting experts are trained to look for things that stay the same, things that are consistent. Sometimes they're things like the way that letters are shaped, the way that letters begin and end. So an exhaustive investigation into the handwriting was conducted, more than just what we're looking at here. And the general consensus was that it was a reasonable match. Anna Anderson's handwriting was very similar to Anastasia's. Good evidence? We'll put it in the pile that we're amassing. Here's another interesting piece of evidence that was used. An analysis of their ear shapes was conducted. So we know we can't use fingerprints. Did you know that the next best thing could be the shape of your ear? The shape of your ear is unique to you, even if you have an identical twin. And when I say the shape of the ear, I'm talking about the folds in the center of the ear, the way the ear attaches to the head. So detectives were able to find some good profile pictures of Anna Anderson's ear. She posed for those, and Anastasia's. Now, these are not the photographs that were used in the real court case. These are photographs that we collected for our own little analysis. And you may be noticing that Anastasia's very young in this photo and Anna Anderson's really old. Does it matter? Apparently, it doesn't. Your ear shape is set. By the time you're a few years old, it should stay the same for the rest of your life. So age should not matter in this ear comparison. So let's take a look at these ears. I will warn you that the quality of these photographs when we zoom in like this is not the best, but you'll get the idea. I'm going to click compare. So look at the folds. Look at the way the ear attaches to the head. What do you think? I see two ears that look very similar. Now, I am not an ear expert. Experts were brought in to do this analysis of both ears, right and left. And they were given a scale or a score, my apologies, of a 4 out of 5. So a 5 would be exactly the same. A 1 would be completely different. They were given a 4. How do you feel about that? Think like a judge. If it was your job to determine if this woman really was the princess, would a 4 out of 5 on the ear test be good enough? Absolutely not. It would have to be a 5. So this was submitted as evidence, but it seemed over and over and over again that there just wasn't enough good, solid evidence, conclusive evidence to prove that this woman really was the princess. So Anna Anderson wound up leaving Europe after the court case was dismissed. The judge determined there wasn't enough evidence to say that she was the princess. There wasn't enough evidence to say that she wasn't. Many members of the royal family had already denounced her. She was very bitter about this decision. And after she left Europe, very rarely granted interviews. There have been some books written about her. She wound up relocating, and that's where she spent the rest of her life. And in 1984, she passed away. To the day she died, though, she said that they were wrong, that she really was the Grand Duchess, the Princess Anastasia. And people who met her often said that they were very compelled by her. There was something special about her, something like an air of royalty. So it would seem that this is the end of the story, but it's not. It turns out, after Anna Anderson's death in 1984, the grave of the royal family was located. So documents had been uncovered that were left behind from the Russian Revolution. One of the documents was actually kind of like a logbook or a journal that one of the Bolshevik soldiers had kept that detailed everyone who was removed from St. Petersburg in 1917 at the start of the revolution, where they were brought, all of the locations. It detailed how the family did indeed end up at the house that I showed you in Yekaterinburg, and that the family was brought to the basement and they were shot at close range. This document also detailed exactly where the bodies were buried. They were in a mine shaft. So what we're going to do now is examine the contents of the grave. In 1991, once the grave was exhumed, all of the remains were brought to another location and examined closely. Now, one thing that we should be aware of is who we're looking for in this grave. It turns out it was more than just the royal family. So here's a list, according to the documents that were found, of the people who were supposedly killed and buried in this grave. So the Tsarina is on this list. All 4 of her daughters, including Anastasia, are on this list. And a nurse. Interesting. So 6 females. The Tsar is on the list, his son, a doctor, and 2 servants are on the list as well. So 5 males. Altogether, how many people should be in this grave? Well, according to the document, there should be 11. So what we're going to do now is we're going to exhume the grave ourselves, but we don't have to go digging around in the dirt. I'm going to take you to an interactive where we can exhume the grave. So as you can see, these skeletons were not carefully placed in the grave. Looks like they might have been buried in a hurry. There are supposed to be 11 people. I can actually exhume this grave by clicking on a skeleton to pop it out. It doesn't seem to be working right now. Hold on. Let's try again. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm out of skeletons. There were only 9 skeletons in this grave. Suspicious? I agree. It's possible this isn't the grave of the royal family. Maybe this is just 9 other people that were put in a grave to throw us off the track. But if the document's correct, and this is indeed the grave of the royal family, we're missing 2 people. Who are we missing? I'm sure you're all thinking the same thing I am. One of them has to be Anastasia. But do we know for sure? We can't go guessing like that. We need some hard evidence. So I'm going to show you how we can look at these skeletons and try to figure out who's missing in a pretty quick, easy way, believe it or not. You can learn a lot about someone by looking at their bones, how old they were when they died, if they're male or female. So here are all 9 of the skeletons that were found in the grave. I'm going to click on skeleton number 1 and show you 3 kind of landmark bones or body parts that we can look at to learn a little bit about this person. First, we're going to look at the teeth. So teeth are really good markers of age. You probably know this. There are molars that grow in at certain ages. Wisdom teeth are the last set of molars to grow into our mouths. Generally, they might start growing in around the age of 18, and it can take several years for them to fully erupt. So for the purposes of our activity, we're going to assume that if someone has wisdom teeth, they're 22 or older. So this is skeleton 1's teeth. And here's a little key. This is what it looks like if someone has wisdom teeth. This is what it looks like if they don't. It looks like skeleton 1 has wisdom teeth, which would indicate that this person, yes, I'm right, is an adult, 22 or older. That eliminates several possible identities. For example, could this be Alexei, who's 13? Could it be Maria, who's 19? Nope. But it could be any of the adults, and there's a lot of them. So let's see if these other bones help. Here's a vertebrae. Do you know what that is? So vertebrae are bones that stack up in our spines. And it turns out that around the age of 18, a bony ring sticks around the outside edge of our vertebrae. Before we're 18, that bony ring is floating. So if you were to look at a vertebrae from someone who's under the age of 18, the ring is invisible. That's useful. Does this person have a ring on his or her vertebrae? I think so. I see it. I'm going to click yes. Let's see what it says. Yes, there's a ring. So this person's 18 or older, which actually is not much of a surprise because the teeth already told us this person was 22. It's okay. Let's go to the next. Pelvis. So your pelvis is your hip bones. Male and female pelvises look quite different. And if you look at the key, you'll see the difference. The female pelvis is much wider. And that's for childbirth. Let's take a look at this person's pelvis. Pretty narrow. Looks like this person is, yes, male. All right, so skeleton 1 is an adult male. How does this help us? I'm going to go back to the list. Who could this be? All right, I'm on the male list here. It could be the czar. It's certainly not Alexei. It could be the doctor. It could be one of these 2 servants. So there are 4 possible identities for skeleton number 1. Was it helpful to look at the bones? Yeah, I narrowed it down a little bit. It doesn't tell me who this person is for sure, but I know who this person isn't. Let's pick another skeleton. Let's look at skeleton number 5. All right, skeleton 5. Wisdom teeth present? Yes. Rings on vertebrae? Yes. Pelvis. Oh, this one looks like A female. All right. We have an adult female. Who could skeleton 5 be? Let's go back to the list. Looks like it could be the Tsarina Alexandra, the mom. Her oldest daughter, Olga, was 22, could be her. The other daughters, no, that could be the nurse. There are 3 possible identities for skeleton number 5. Useful? Yeah. So to save time, what I'm going to do is I'm going to click ahead to skeleton number 9, where I can access all the information for all the skeletons. Let's see what you think. So skeletons 1 through 9 are across the top. Below each skeleton, it tells me whether that person has wisdom teeth or not, rings on vertebrae, and pelvis shape, whether it's male or female. I always start down here with male or female. So it looks like there's 1, 2, 3, 4 males. The list had 5 males, so it looks like one of the missing people is a male. That would mean the other is a female. Let's make sure. 1, 2, 3, 4, 5 females. We're missing 1 male and 1 female. Interesting. The plot thickens. The next thing I notice, I don't know if you noticed this, but there's something everyone in the grave has in common. Everyone in this grave was 18 or older. This is very telling. I'm going to go back to the list, and if you haven't figured it out, you're going to. Why is this so important? There were only 2 people under the age of 18 on this list. Alexei, who was almost 14, and Anastasia, who was 17. Based on the evidence that we see from these skeletons, it looks like the 2 youngest are missing from the grave. Everyone else in the grave had those rings on their vertebrae. They had to have been at least 18 years of age. Oh my gosh. I don't know if you're thinking what I'm thinking, but Anastasia's not in the grave. That's a big deal. Maybe Anna Anderson was telling the truth. The wheels are spinning in my head, but I have to put on the brakes. Because have I proven yet that these 9 people are actually members of the royal family? I have not. How are we going to figure out if these 9 people, some of them at least, are members of the royal family? Now, don't forget, when this grave was found, it was 75 years after the family had died. It was 1991. What can we do in 1991 that we couldn't do back in the 1920s? We've got a tool at our disposal now in 1991 called DNA. And all of these bones are made of bone cells, and those bone cells contain DNA that can be extracted and analyzed. So that's what the scientists did next. And the DNA that they extracted has an interesting story. It turns out that the DNA that was used to identify the people in this grave was from a part of the cell called the mitochondria. This is a big picture taken with an electron microscope of a mitochondria. Mitochondria are called the powerhouse of the cell. In animal cells, they make energy. The cool thing about mitochondria is that they have their own chromosome. There is DNA inside the mitochondria separate from the DNA in the nucleus. Now, what does the DNA in the nucleus do? All the DNA in the nucleus is the DNA that we've inherited from our parents, the genes that will determine our traits, things about the way we look, things about the way our bodies function. But we also inherit mitochondrial DNA that does something else. It actually contains the genes that the mitochondria need to do their job, to make energy. So there's a single chromosome, and there can be lots of copies of it, that just has the instructions that that little organelle, that powerhouse needs to do its job. But here's the cool story about mitochondrial DNA. It's inherited in an interesting way. So it's different from the DNA in the nucleus that's half from mom and half from dad. Mitochondrial DNA is inherited maternally. What that means is that DNA you only inherit from your mother. So I'm going to show you how this works on this little pedigree. Every circle you see is a female on this family tree or pedigree. Every square is a male. And then there are lines connecting these people that all mean things. There's a little key here, but I'll show you also. The two people on the top, that female and that male, there's a union between them. And from their union sprang two children. They're connected by a downwards line that connects them to their daughter and their son. So siblings are connected by a sideways line, but that sideways line is connected to upwards lines first. Unions directly connect two people. So we have mom and dad, and here are their two children. Here's son. Son has a union also, and from his union, there are two children, a daughter and a son. Same thing over here. A son, oh, someone else's son, a daughter who married this lovely gentleman, and they're connected to their children also. So let's say this is grandma up here. These are the grandchildren. I want to know who in this family will inherit grandma's mitochondrial DNA. Let's see. It's passed from mother to child. Both of grandma's children inherited exact copies of her mitochondrial DNA, her son and her daughter. Everyone has mitochondrial DNA, male or female, but the difference is that males don't pass it on. So this son's children, their mitochondrial DNA will match who? Their mothers. But here's daughter. She has two children. They inherited that same exact mitochondrial DNA. So how many people in this family have the same exact mitochondrial DNA? 1, 2, 3, 4, 5 people over 3 generations. And what's really cool about it is that when it's passed, it's not mixing with dad's mitochondrial DNA. So it pretty much stays the same one generation to the next. For many generations, it can stay the same. That's useful in our case because the people that we're identifying died a long time ago. In fact, here's a family tree for the royal family, the people that we think are in this grave. Down here is Tsar Nicholas and his wife Alexandra, and they're connected by a downwards line to their children. So there's Alexei, Anastasia, the sisters. And way up on tippy top is Anastasia's great grandma, Queen Victoria. She was the Queen of England in the 1800s, pretty famous. She was married to this gentleman, Princess Albert, had a whole bunch of kids. One of those kids was Anastasia's grandma, Alice, who had a whole bunch of kids. There's Alexandra. These are Anastasia's first cousins beside her. And I think that these are called first cousins once removed. Many generations of people. 1, 2, 3, 4, 5. Here's the issue. These people, we think they're in the grave. We're going to extract DNA from their bones, and we're going to compare their DNA, mitochondrial DNA, to someone else in the family. So we, number one, need to find a family member whose mitochondrial DNA will match them. And number two, it would be nice if that person was alive. I'm most likely to find living people on the bottom of the tree. Those are the youngest people. Let's see who in this family has the same mitochondrial DNA as the Russian royal family. Whoa. It's a lot of people. So Alexandra matches all of her children, makes total sense. They match together a whole bunch of other people, including Queen Victoria on the tippy top of this family tree, all the way down to this guy, Prince Philip. So we have lots of options, but don't forget, we need someone who's alive. So in 1991, when this DNA analysis was conducted, the reference DNA, the DNA that we're going to compare to the people in the grave to see if they're members of this royal family, was Prince Philip, who is still alive. He is, well, do you know who he is? He's a very famous husband. His wife is Queen Elizabeth, the Queen of England. His son is Charles. His grandchildren are William and Harry. Very famous people. So his mitochondrial DNA, interestingly enough, will match Alexandra's, Olga's, Tatiana's, Maria's, and Anastasia and Alexei. Will he match Nicholas? No. Why not? Yeah, so Nicholas is from another family. He inherited his mitochondrial DNA from his mother and grandmother before her. So we'll look at his family tree in a minute. Same thing goes for poor Prince Albert up here, who is Queen Victoria's husband. His DNA is different. He's not what we would call a blood relative. So in 1991, Prince Philip's DNA was used to identify some of the people in the grave. So let's think about this. He would match Alexei, but is Alexei in the grave? No. So according to our first analysis, he's not. He would match Anastasia. Is she in the grave? It looks like she's not. So for now, we're not going to think about those two. We'll come back to them. It looks like Maria, who should be in the grave, Tatiana, Olga, Alexandra, they should all match Prince Philip. And they all have something in common, which makes our job easier. They're all females. So what we can do is just look at DNA from the females in this grave and see if their DNA matches Prince Philip's. If it does, what does it tell us? It tells us that they're related. They're members of the same family. So let's just see if that works out. I'm going to show you how to look at their DNA. So what we're doing now is we're looking at something called an alignment. An alignment is when you have DNA sequences from a bunch of different people or living things that you want to compare to each other all at once. So it looks like here we have skeletons 3, 5, 6, 7, and 9, their DNA over here, and Prince Philip's DNA also in this alignment. Do these letters look familiar to you? If you tuned in on Monday to Mrs. G's lab, you might have learned a little bit about DNA structure. So within the double helix, there are these chemicals called bases. We call them A, T, G, and C for short, and you can see them all represented in these sequences. They're in a special order or sequence. When we're comparing mitochondrial DNA between people, all we're doing is looking at the sequence of these bases to see if it matches. So it looks here in this position 1 like everyone has a C. Skeleton 3 has a C, 5, 6, 7, 9. Even Prince Philip, our reference, has a C. Here in position number 2, it looks like everyone has a T. Position 3, everyone has a G. Whoa. So all the way up through position 25, if you look closely, all of their DNA is exactly the same. Are you surprised? I'm a little surprised, but you know what? It turns out that as humans, we share a lot of the same DNA. Sometimes finding the differences is like finding a needle in a haystack. So I'm going to scroll down a little bit. And what this computer program does is it highlights differences for me. So I don't have to waste time looking at DNA that's all the same. So it looks like here near almost base number 100, the computer's telling me to look. So let's see, skeleton 3 has a T, 5 has a T, 6 has a T, 7 has a T, 9 has a C, and Prince Philip has a T. So the first 4 skeletons still match Prince Philip, but it looks like this outlier, skeleton 9, doesn't match. Does this mean anything? It could mean she's not related to the others. That's interesting. Is it possible that it's just like a random mutation that happened in one person in the family? I suppose. So you know what I'm going to do? I'm going to keep looking and see if there are any other areas that this computer program has highlighted. Whoa, we've got a whole cluster of them. All right, here's another one. C, 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 T, C. Again, skeleton 9 is a T. Everyone else has a C, including Prince Philip. Here's another. C, 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 T, C. Skeleton 9 again. Skeleton 9 again. Every time the computer finds a mismatch or a difference, it belongs to skeleton 9. So I think we have some pretty conclusive evidence here that skeleton 9 isn't related to Prince Philip or these other skeletons. Now, who could that be? Is there a female on the grave who's not related to the others? I always forget about her. The nurse. It looks like skeleton 9, based on her age, she's an adult, we've got a female, and her DNA profile here. She's the nurse. She's not related to the others. What about skeletons 3, 5, 6, and 7? If we went all the way through, what we'd see consistently is that their DNA is exactly the same as Prince Philip's. What does that tell us? It looks like they're his relatives, based on the fact that they're in this grave, and we have a document saying who was in the grave, their ages, the fact they're females. It looks like we have identified Alexandra, the mother, and her 3 daughters, Maria, Tatiana, and Olga. They've got the same DNA as Prince Philip. They're his relatives. So the DNA tells us that some of these people in the grave are definitely members of the royal family. Very useful. I'm going to show you how to identify the Tsar also. So here's the Tsar's pedigree, his family tree. Can you find him? Here he is, Nicholas II. So the first thing I want to do is find a relative whose DNA I can compare to his who's still alive. Whoa, again, it's a lot of people with matching mitochondrial DNA. Lots of people to choose from. This is whose reference DNA was used, Countess Xenia. So out of the males in the grave, there should be one male, Tsar Nicholas, who matches the Countess. The other males are the doctor and the servants. So let's see if that pans out. So skeletons 1, 2, 4, and 8 are the male skeletons. So we're looking at their DNA sequences here. Here's the Countess. Again, most of their DNA is the same. Not a surprise, they're humans. Let's see if we can find, oh, all right. TTCTC. So let's look at Countess Xenia first. She's got a C. So it looks like skeleton 1, 2, and 8 are different in this spot. But skeleton 4 has the same base as Countess Xenia. Interesting. Maybe skeleton 4 is the Tsar. But again, we should keep looking. You might have noticed the little gray area here where there's an N. There's no N's in DNA. What that means is that when the DNA was isolated from the bones, maybe it was damaged and we weren't able to figure out what that base was. So it's inconclusive and the computer program inserts an N. If it's shaded in gray, I can't use it. So I'm going to skip that. Here's some more yellow. So what we want to see here, Countess Xenia. In this spot, there's a few of them that do. Down near base number 275, only skeleton 4 matches Countess Xenia. And again here, only skeleton 4 matches. So it looks like skeleton 4 is Tsar Nicholas. His DNA profile matches the Countess perfectly. So we've identified that we have the right grave. We know that we have members of the royal family. We've identified the Tsar and his wife and their 3 oldest daughters. And yet I'm drawn back to the missing. What of Anastasia and her brother? It looks like maybe at this point, Anna Anderson was telling the truth. If she was, is there a way to figure out that she really was Anastasia or not? Well, if she's the daughter of the Tsar, Anna Anderson's DNA would match Prince Philip's, just like the sisters and the mother. So if I have Prince Philip's DNA already, can I compare Anna Anderson's DNA to Prince Philip's? Yeah, in 1991, that's what was done. There was a little bit of a roadblock though. When Anna Anderson died, her body was cremated. That means burned to ashes. You can't retrieve DNA from ashes, it gets destroyed. So they had to be creative in how to get Anna Anderson's DNA. And there were 2 sources. It turns out Anna Anderson's husband saved some of her hair. Sometimes you can isolate DNA from hair. The other source was an intestinal sample, a tissue sample that had been removed from her body before she died and was still being stored in a freezer. So there were 2 sources of Anna Anderson's DNA in 1991 that could be extracted and compared to the reference to Prince Philip. So let's think about this before we look at the DNA. Anna Anderson, for a long time, claimed to be Anastasia Romanov. If she was being truthful, her DNA will match Prince Philip's, just like her mother and her sisters. Is it possible that she was a fraud? It is. It doesn't seem likely, but it is. So what we're going to do also is investigate the lead that that journalist in Germany had back in the 1920s. Maybe he was right. Maybe Anna Anderson was really that Polish factory worker, Franciszka Szankowska. It seems like a stretch, but I suppose it's possible. If we were to use DNA to determine that Anna Anderson was really Franciszka, this Polish factory worker, we would have to find one of Franciszka's relatives. And that was done in 1991 a nephew was found in Poland. His name was Karl Mosher, and he provided a DNA sample. So what we're going to do now is look at Anna Anderson's DNA extracted from hair and intestine, and we're going to compare it to Prince Philip's DNA and to Karl from Poland. Hopefully her DNA sequence will match one of them, and we'll know who Anna Anderson really was. If she doesn't match either of them, all we know is she was lying. Let's see. Okay, so we have an alignment. Anna Anderson's DNA sequence is on the top. In the middle is Karl Mosher from Poland, so he's related to Franziska. And then Prince Philip's DNA is on the bottom. And again, mostly the same. Let's scroll down. Dun, dun, dun. I'll give you a moment to process. It looks like Anna Anderson, let's look at this spot here near base 100, has a C. Karl has a C. Prince Philip has a T. Second, C, C, T. I'm going to scroll down. Got a pit in my stomach right now, people. T, T, C, C. Do you see what I see? What can we conclude from this DNA alignment? What I'm seeing is that Anna Anderson's DNA matches Karl's exactly. The person who's not matching here is Prince Philip. Every time the computer has found a difference, it's Prince Philip's DNA that doesn't match. So what does it all mean? Well, it looks like Anna Anderson was indeed a fraud. This DNA tells me that she was not a member of the royal family, not related to Prince Philip. It also tells me that she's related to Karl. Her mitochondrial profile, the sequence of her DNA, matches his exactly. So I'm going to go back a screen. It looks like the DNA is telling us that Anna Anderson was actually Franziska. She was a Polish factory worker who looked a lot like a princess, was very good at acting like a princess, who actually fooled a lot of people. But she was a fraud. She was not a member of the royal family. We can't go back and ask her why she lied. We can maybe have some educated guesses about it. Some people believe that Anna Anderson convinced herself at some point that she really was the princess, and that when she died, she believed it. She really, truly believed that she was. But unfortunately, the DNA is telling us otherwise. And then the next logical question is, well, what happened to Anastasia and her brother? Well, it turns out that years after the grave was exhumed, a second grave was located. Yes, very close to the original grave, a few hundred meters away, I believe. A second grave was found accidentally, and the remains of two people were found in this grave. It was identified right away that one was a male, one was a female. And then after an exhaustive DNA analysis, it was shown that the two people in this grave were also members of the royal family. So the two missing people happened to be in a second grave the whole time. What a fantastic story. I hope that you enjoyed it. I'd like to tell you that on one of our websites, we have a lot of the interactives that I just showed you, and more movies and even interviews with some of the detectives that were involved in the DNA analysis of this true story. If you'd like to check it out, go to our website, DNA Interactive, and you'll find an activity called Recovering the Romanovs. The information about how to access Recovering the Romanovs is also in the resources section on the DNALC live site. It's on the top of every worksheet page in the workbook. So now that you know the story, you can show other people the story of the mystery of Anastasia. I hope that you enjoyed today's presentation, and I hope also that you'll be checking into future DNALC live sessions. I had a great time today. Take care.